Okay, so here we have a projectile. Is projected at an angle of 60 degrees from the horizontal with a speed of the square root of 3 plus 1 meters per second. Find the time in seconds after which the inclination of the projectile with the horizontal becomes 45. So what we've got here, got our projectile. So what happens there now is that's 60 degrees and V0 is actually root 3 plus 1. So I can get my velocity vector, which is V0 cos theta I plus V0 sine theta minus 9.8 Tj, and then I can substitute in V0 and theta. So V0 is root 3 plus 1 cos 60 in the I direction plus root 3 plus 1 sine 60 minus 9.8 T, all in the J direction. Okay, so I can simplify. Alright, so cos of 60, you can use your special triangles. It's not working today, is a half, so that's actually root 3 plus 1 on 2 I, and then sine of 60 is root 3 on 2 all in the J direction. Okay, we could simplify it a little bit more if we wanted to. We could expand through, but I might just leave it there to start with. So the next part, it says find the time in seconds after which the inclination of the projectile with the horizontal, so with the horizontal, becomes 45. So I want to know when that angle there equals 45. So, what do I know about this? So, if you go to your special triangles, and I have an I component here and a J component. So if I do tan of 45, it's equal to 1, isn't it? Okay, so tan 45 degrees equals 1. Okay, so I know that tan of 45 or tan of the angle has to equal opposite over adjacent, and that opposite over adjacent has to equal 1 for that to be true. So if I look here, tan of 45 degrees is equal to J over I and that has to equal 1. So for my inclination to be 45 degrees, tan of the angle is going to equal 1, okay, or 10, and in this case it's 45 degrees equals 1. So tan of 45 is equal to my j component divided by my I component, which should equal 1. Okay, so this is my j component, so I have root 3 plus 1, root 3 divided by 2 minus 9.8 t. All of that divided by root 3 plus 1 on 2, and all of that should equal 1. So now I'm going to go and multiply 1 by all of this. So all of this times 1, so I've got root 3 plus 1, root 3 on 2 minus 9.8 t equals root 3 plus 1 on 2. I'm going to now just move my camera a little bit straighter, sorry. I'm going to multiply through by 2 to get rid of these 2's here. So if I multiply by 2 on this side, that 2's gone, so I'm left with root 3 plus 1 times root 3 minus 9.8 times 2 is 19.6 t, and if I multiply by 2 on this side, those 2's cancel, so I've got root 3 plus 1. Alright, I'm going to just do some basic rearranging here, and minus root 3 plus 1 times root 3, and that's equal to negative 19.6 t, so root 3 plus 1, root 3 times root 3 is just 3, so that's minus 3, minus root 3, negative 19.6 t, that's gone with that, and we've got minus 3 plus 1 is minus 2, 2.6 t, so t equals minus 2 divided by negative 19.6, that's 0.1 seconds. So therefore, after 0.1 seconds, the projectile will be at an inclination of 45 degrees.